Welcome back to the class of Res Econ 313. So starting today, we'll look at Chapter 11, where we look closely at a person's risk attitude and figure out how we can apply what we know about any person's risk attitude to decisions, problems, and then to figure out values of different uncertain deals for a person. So just a heads up about this chapter. This is going to be a very hard chapter, and you'll see a lot of notations and a lot of math. So sharp up your mathematical skills and then take a deep breath before you watch this video. Okay, there are 3 topics that we're going to cover, and we're planning to use 4 classes to cover this. So this video that you are watching will be the first 2 classes. Okay. In this first topic, we're going to look at what is a delta property, and then if a person has this delta property, then we call that person a delta person. And essentially, when we're describing a person with or without delta property, we are essentially describing, does wealth have any effect on a person's risk attitude? Okay, so I'll explain this in details now. So here is a brief review about what we learned so far about risk attitude. Okay, so everyone recognizes by now that this is an uncertain deal where you have half of the chance to receive $1,000 and half of the chance of receiving nothing, $0. Okay, so we are concerned with a lot of uncertain deals in this class. Essentially, everything is uncertain. A party problem can be converted into several uncertain deals with different prices and different probabilities of getting the prizes, right? So we are interested in how people value uncertain deals in various situations. And then what we are most concerned about is to choose the best option that lead to the best uncertain deals. And that is exactly how we approached analyzing Kim's party problem. And also we used that approach to analyze the value of perfect information for Kim in the party problem. Okay, so an uncertain deal is what we are looking at. Well, every uncertain deal has a property called expected value, right? So we have talked about this before. The expected value of this uncertain deal is equal to the probability times each price, and then we add all those up, which means the expected value of this uncertain deal is $500. So this is something very objective, okay? No matter who you are, the expected value of the uncertain deal is the same for you. It represents the average payoff that you're going to get if you play this uncertain deal for a lot of times. So if you play this for 100 times, then on average, each time you have an average payoff of $500. Okay. So this figure, expected value is the same for everyone given an uncertain deal. It represents something objective about this uncertain deal. Okay. So what we are interested in now is the certainty equivalent of an uncertain deal, which is just not the same, generally not the same thing as the expected value. Okay. Using the technical terms learned in this class, the certainty equivalent of an uncertain deal is just the dollar amount such that when received for sure, that would give a person the same U value as the deal. Okay, so a person receives the certainty equivalent dollar amount for sure, gets a U value there. A person receives this uncertain deal, gets a U value there. So the 2 U values should be the same. Okay, So generally, you will need to look at a person's yield curve to find the person's certainty equivalent of an uncertain deal. Again, there are 3 steps for that. First, you need to find the yield values of all the prices in the uncertain deal. Then you would find the yield value of this uncertain deal. That would be 0.5 times the yield value of $1,000. 0.5 times $0, the yield value of $0. That gives you the yield value of this uncertain deal. And the last step would be to look at the yield curve again and figure out what kind of dollar amount gives you such a yield value, okay? So when we have figured out a person's certainty equivalent, then a person will be equally happy if you give the person her certainty equivalent of the deal, or if you give her this uncertain deal instead, okay? So we have already learned this, just a review, that the certainty equivalent essentially represents the value of an uncertain deal to a person, okay? It is also equal to a person's willingness to pay for the deal. Again, willingness to pay is the highest price that a person is willing to pay to have the uncertain deal, okay? And based on the relationship, certainty equivalent is different, may be different for each person, okay? This represents a person's subjective value of any uncertain deal, versus expected value represents some kind of objective property of an uncertain deal. So EV, expected value, is the same for everyone. However, certainty equivalent may be different from one person to another. And then based on the comparison between certainty equivalent and expected value, we have defined whether a person is risk-averse, risk-loving, or risk-neutral, okay? When a person has a certainty equivalent that is below the expected value of the deal, then we say that person is risk-averse. When a person has a certainty equivalent that is equal to the expected value, then that person is called risk neutral. And if a person's certainty equivalent is above the expected value, then that person is said to be risk loving, okay? So these are the things we learned in chapter 10. And if you're still confused about all these concepts, please review chapter 10 to get a better idea. Otherwise, you will get super lost in chapter 11, because we are going to look at all these things again in a more detailed way in chapter 11. Okay, so now we have already understand the difference between the 3 classes of people. You know, the thing is, even if you look at 2 people, 2 persons who are both risk averse, you can also compare these 2 persons to say who is more risk averse than the other, okay? So now we're going to talk about the degree of risk aversion across different people. So here we're looking at the same deal as we saw in the previous slide. And we have 2 people here. And we ask them about their certainty equivalent, or their value, or their willingness to pay for this same uncertain deal. Now suppose this is what we get from these 2 people. The first person tells you that his certainty equivalent of this uncertain deal is $400. The second person tells you that his certainty equivalent for this deal is $450. Okay, so this is what we know about these 2 persons, and this is their subjective value of the same uncertain deal. The first look at the 2 persons' value tells us that both person 1 and person 2 are risk averse, right? Because the expected value of the uncertain deal is $500. Both $400 and $450 are below $500, which means we have two risk-averse people over here. Now the question is, which one of these two persons is more risk-averse than the other? Okay, so as you can see, the difference between the certainty equivalent and the expected value over here is $100 for person 1, which means, however, for person 2, the difference between $450, the certainty equivalent, and the expected value of this uncertain deal, $500, is $50. You know, the further below the certainty equivalent is in comparison to the expected value, the more risk-averse that person is. So the difference between the certainty equivalent and the expected value can be seen as the sort of the cost in order for a person to accept some uncertainty over here. The cost of accepting this uncertainty is $100 for person 1. The cost of accepting going from a certain thing to an uncertain thing is $50 for person 2. So person 2 has a lower cost if you shift him from certain deal to uncertain deal. And person 1 has a $100 cost if you shift her from a certain deal to an uncertain deal. So in that sense, we say that person 2 is less risk-averse than person 1. Okay, and the way to get to that is comparing different people's certainty equivalent of the same deal. Those who have a higher certainty equivalent of the same deal is less risk-averse than those who don't. Okay, so over here, if we look at these two people, this person is less risk-averse than this person because he has a higher certainty equivalent. Okay. Now, knowing this, let's look at what kind of effect that a person's wealth may have on his or her risk attitude or on his or her levels of risk aversion. Okay, we're seeing that these are two persons. However, if you imagine it, these two could be the same person, but having at different time. So if you are poor, you might be person 1. If you are richer, you might be person 2. That means your risk-averse degree may change from time to time, depending on how much money you have. Okay, here is an example of that. Let's say we're looking at a person called Jim, who began as person 1. Person 1 over here. That is where he began. So this is when he has $1,000 in the bank. Okay, as you can see, these prices are, the higher prices are almost the same. Well, it's the same as all the wealth that Jim has in the bank, and this is a significant risk. And the difference between these two prices are very huge compared to Jim's bank account balances. Okay, and this is what Jim values this uncertain deal at, with only $1,000 in the bank. Now suppose that 10 years has passed and Jim has worked and accumulated a lot of wealth, and now he has, well, $1 million in the bank. Okay, so potentially two things could happen. The first scenario is that despite of having the same kind of much more money in the bank, Jim is equally risk averse as he was when he had only $1,000 in the bank. So if you give Jim this same deal as he may be faced before, he will have the same certainty equivalent of the deal. So this could be one of the scenarios that happens. Okay. In a different scenario, Jim may become less risk averse now that he has much more money. So if you ask Jim again after he has accumulated this $1 million wealth in the bank, then he may value this uncertain deal like person 2. Okay, this is very realistic, and this can potentially happen, and when this happens, that is totally reasonable. If you think about that, now he has more money. He doesn't suffer so much from the uncertainty between receiving $1,000 and $0, because compared to his wealth, these two prices are just not that significant. And then he doesn't hate the uncertainty of this uncertain deal as much as he did when he was poor. So now he values this uncertain deal at a higher certainty equivalent. Okay, so if this happens, we say that Jim is less risk averse as he becomes richer. If this happens, we say that Jim is equally risk averse as he was when he becomes richer. Okay, either of these two scenarios could happen. Well, actually, as you can imagine, there could be a scenario 3 where Jim actually becomes more risk averse as he has more money in the bank, which means this certainty equivalent would be lower than $400 after he has more money. Okay, so that is scenario 3, which is not drawn over here, but also possible. Okay, so this is how we envision or how we imagine that a person's risk attitude could change when his or her wealth changes. Okay, so the relationship between people's risk averse and people's wealth level is captured by something called the delta property. Okay, so if scenario 1 happens, meaning if a person's risk attitude does not change no matter what his or her wealth level is, then we say that the person is having something called a delta property, and we call that person a delta person. Okay, and if this scenario 1 doesn't happen, if he either becomes less or more risk averse as he grows more wealth, then that person is not a delta person. So here, delta person refers specifically to the situation, to a person whose risk attitude doesn't change. As long as the risk attitude changes, no matter to which direction, more or less, that person is called a non-delta person. Okay. Okay, to clarify, this is what we look at using a risk-averse person. This concept of delta person is also applying to those who are risk-loving or who's risk neutral. Okay, for a risk-loving person, if his or her wealth level doesn't affect his or her degree of risk-loving, then that person is also a delta person. Well, then for a risk-neutral person, if his wealth level doesn't change him being a risk-neutral person, then that person is also called a delta person. So what that means is a delta person could be risk-averse. He could also be risk-loving. He could also be risk-neutral. As long as the level of risk-averse or risk-loving or risk-neutral doesn't change with respect to that person's bank account level or wealth level. Okay, so that is a very important clarification. Delta person is not necessarily only a risk-averse person. Okay, so before we formally define what is a delta person, I want you to look at these 3 deals and then think about this question. Okay, so this deal, this equivalence relationship is made by Jim when he has $1,000 in the bank. And these two, either one of these two equivalence relationship is made when Jim has $1 million in the bank. So here, the bank level or the wealth level is marked at the top. There is another way to look at Jim's wealth, okay? So suppose we don't want these two green boxes and we want to integrate the wealth into this equivalent relationship. Here's the way to do that. So alternatively, you could just add $1,000 to both sides of the equivalence relationship, okay? And this means that, either you give Jim $400, so now in that scenario, he'll have $1,400 in his bank account. Or if you give him the uncertain deal, and if this happens, if he happened to receive the higher price, then he would have $1,000 from the price plus the $1,000 in the bank. So in this scenario, he'll have $2,000 in the bank. Okay, if the other scenario happens where Jim acquires only 0 price from the uncertain deal, then together with the original $1,000 in the bank, he'll have $1,000 in the bank. Okay, so if we add this $1,000 from the bank to both sides, we no longer need this sentence to represent Jim's wealth level. Okay, so you can just erase this. Similarly, what we can do over here, so now Jim has $1 million in the bank. So instead of saying that Jim has $1 million in the bank, we could just add $1 million to both sides, to each price and the certainty equivalent, which means this scenario is you give Jim $400, then he'll have this much in the bank account. And if this happens, he'll have this much in the bank account. If this happens, he'll have this much in the bank account. And similarly, if the other scenario happened, then you could just add it. So when you have the wealth level added to the equivalent relationships, you no longer need those two green boxes to remind you when the equivalence relationship is made, under which wealth level is the equivalent relationships made. Okay, so this is an alternative way to look at the wealth component. A wealth is essentially the same amount of money that is added to all possible scenarios of the equivalence relationship. Okay, so this representation is the same as this representation. Okay, $1,000 is when this is made. $1 million is when either one of these are made. Or you could have $1,000 is when this is equal. $1 million is when this is equal, or this is equal. Okay, so different ways to look at the combination of wealth level and the uncertain deal. Okay, so with this understanding, we're now ready to formally define the delta property. Okay, so here we are looking at an arbitrary deal, and here is the first abstract notation you will have. Here the tilde sign is the same as the equal sign. We use these two interchangeably in this class. So here you have some uncertain deal that has P1 probability of receiving X1 and P2 probability of receiving X2 and P3 probability of receiving X3. And the certainty equivalent of this uncertain deal is represented by X tilde. Okay, so now this is the deal. We refer to this deal as X deal, here X deal. And this is when you have W0 in your bank account, and your certainty equivalent for this delta, for this X deal is X tilde. So this is the first equivalence relationship that you have identified for yourself. Okay, and this is just an explanation of what deal X means. This deal X means. Okay, now suppose that we increase X tilde by something called delta. I'm sorry, if we increase all the prices in this uncertain deal by the same amount of dollar, which we use delta to represent that. So delta could be $10, $100. It can also be a negative number, which means you are reducing the prices by the same kind of dollar amount. Okay. Now the question is, what will be your certainty equivalent for this new deal with delta added or subtracted from the prices? Okay. Now, if you satisfy the delta property, then your certainty equivalent for this new deal would be your original certainty equivalent plus the amount that is added to each price in the uncertainty. Okay, here delta can be positive or negative. So this is the definition of delta property. Adding the same kind of dollar amount to all the prices will add also the same amount of dollars to the certainty equivalent. Okay. So this is the definition given in the textbook. And here, actually, if you look at this delta property, this new relationship that comes from the delta property, you would think that adding deltas to all these things is to all the prices is essentially equivalent to adding delta to your initial wealth, W, right? W0. This means no matter what happens, if this happens, you get x1 plus delta. If this happens, you get x2 plus delta. If this happens, you get x3 plus delta, which means no matter which case happens, you always get that delta amount that you can safely put in your bank account, which means, well, this means that essentially your wealth level is changed by this amount, delta, okay? And then over here, your certainty equivalent is equally changed by that amount. So the alternative way to wield this delta property is that if you add delta dollars to a person's bank account or to a person's wealth level, which means now instead of having W0, you have W0 plus delta in your bank account, then your certainty equivalent of the original deal is still X tilde, okay, which means if you just cross these deltas away, the certainty equivalent for this deal is still X delta. Okay. So this is one way to describe the delta property. This is another way to describe the delta property. These two ways are different ways to wield the delta property, but they are the same thing. And essentially, a delta person is a person who's risk averse or whose risk preference satisfies the delta property. That is, a person's risk aversion or loving or neutral doesn't change with the changes in her wealth. Okay. So now this is what happens if a person satisfies delta property, or equivalently, a person is a delta person. Well, if a person is not a delta person, then this number over here would be changed, okay? Would not be equal to X tilde plus delta, okay? Now, this is what happens when you add delta dollars to a delta person's deal. And what happens if you add delta dollars to add this delta amount to a person who's not a delta person, then the certainty equivalent will not be equal to x tilde plus delta. It will be either higher than x tilde plus delta or lower than it. Okay, so this is the introduction example as well as the definition of the delta property. What we're going to look at next are a couple of exercises to help you better understand how to tell if a person is a delta person or not. And on the other direction, if you know a person is or is not a delta person, what you can do about that. Okay. So this first exercise that you will be seeing is this. Okay. So you have known someone called Kim already, and this Kim person has indicated these two equivalent relationships to you. And this is what she told you about herself. Now the question is, looking at these two relationships, can you tell if Kim is a delta person or not? Okay, so I'll give you 10 seconds to look at this and try to figure out the answer to this question for yourself. Okay, the key thing in order to tell whether Kim is a delta person or not is to compare first the two uncertain deals. Okay, so the uncertain deal in this relationship is half chance of $100 and $0. The uncertain deal over here is half chance of $120 and $20. So comparing these two uncertain deals, you'll notice that this second uncertain deal is essentially, we got this uncertain deal by adding $20 to the first uncertain deal over here, right? $100 plus 20 is $120. $0 plus 20 is $20. So this second uncertain deal is the first uncertain deal with $20 added to the prices. Okay, so that is what happens to this uncertain deal. And over here, if you compare the two certainty equivalents, the original certainty equivalent for the first deal is $34. The certainty equivalent for the second deal is $54. The difference between these two uncertain deals is equal to 20. So this actually, we can sort of write that observation like this. So now the first uncertainty, $54 difference between $34 and $50 is 20. So we break that out. $120 is equal to $100 plus 20. $20 is equal to $0 plus 20. So this second relationship, if we write it like this, then it is abundantly clear that Kim is a delta person, because when we add $20 to the prices of an uncertain deal, the certainty equivalent is equal to the original certainty equivalent plus that same amount of dollars. Okay, so by rewriting the second equivalent relationship into this breakdown format, we can easily tell that Kim is indeed a delta person. Okay, so now the second exercise is that Alex, who's not the same person as Kim, also indicated his certainty equivalents for these two uncertain deals. And this is the first one and this is the second one. Now the question is Alex a delta person? Okay, so Alex's certainty equivalent for the original deal is actually the same with Kim by accident, but his certainty equivalent for the second deal is different from Kim's. Now, looking at these two certainty equivalent relationships that Alex has, you should be able to answer whether Alex is a delta person or not. So now you can tell by looking at the problem similarly as we did for Kim. Okay, so again, this second deal is, again, we got it by adding $20 to the first deal, okay? However, in very different from Kim, this new certainty equivalent, $60, is not equal to the certainty equivalent from the original, from the first deal, plus this $20 amount, okay? Since the certainty equivalent of this new deal is not equal to the certainty equivalent of the original deal plus the $20, then Alex is not a Delta person, okay? As a matter of fact, if you subtract $20 from the $60, you would think that this would be equivalent to, after you add $20 to Alex's bank account, then he values this uncertain deal at $40, which means he's less risk averse. Okay, so these are different ways to look at the same problem. If you break this $60 into $40 plus $20, then that $40 would be the new certainty equivalent for the original deal after you put $20 into his bank account. So these are consistent with the two approaches that we are looking at the Delta property. Okay. And here is just a recap of what I just said. Okay, so now we're breaking $60 into getting the $20 out of that $60 leaves us $40. Meaning for a Delta person like Kim, if we give her $20 in the bank account, put it there safely, and then she views this uncertain deal that we had originally constructed the same at $34. Over here, with this person's, the second person, Alex, is viewing this uncertain deal at $40. Okay, so you can sort of get rid of the common component, $20, of this second deal. Subtract 20, subtract 20, subtract 20, you got 40 equal to 0.5, 100, 0.5, 0. That is what we have over here, okay? Delta person, not a Delta person. Here, the two exercises we've just seen are the one type of question you might encounter, which is giving you certain some relationships for you to decide whether a person is Delta person or not. Now, the second type of question you might encounter is that you're told whether a person is a Delta person or not. Then you're asked to sort of judge something based on that. So now the first question may be like this. Now we know Kim is a Delta person. Okay, so this is what Kim told you. I am a Delta. My certainty equivalent or my risk attitude is not affected by my wealth level. And then she also told you that her certainty equivalent for this binary deal is $34. Now the question becomes, what will be Kim's value of this new deal, deal A? Okay. So these are not the same type of questions or in any way related to the previous two exercises, to be clear. So all you know for this question is what is on this slide. Okay, I'll give you 10 seconds to think about this problem. Okay, so our target or our task is to sort of deduct how much Kim values this new deal that we call deal A. Okay, if we compare deal A with this deal, we have identified that this deal A is derived from the original deal by add $100 to each prices. Okay, so add $100 to $100, you got $200. Add $100 to $0, you got $100. So deal A is different from this deal by adding $100 to each and every price of the original deal. Now we know Kim is a Delta person, so we know his new certainty equivalent would be equal to the original certainty equivalent plus the amount that is added to the prices. So the question mark would be equal to $34 plus $100. So $134 would be the certainty equivalent for this new deal, deal A. Okay. So next question. So again, we're looking at Alex, who is less risk averse as his wealth increases. And he also told you that his certainty equivalent for this binary deal is $34. Now the question is, which one of these four options, these four candidate options, can be Alex's certainty equivalent of this new deal? So now we know Alex is less risk averse as his wealth increases, meaning his risk attitude is changing with respect to his wealth, which makes Alex not a Delta person. Okay, so that's why option A is not correct, because option A, as we have figured out, if Alex values new deal A at $134, that would mean Alex's risk attitude is not changing as his wealth increases, which also means Alex is a Delta person. So the option A would be the certainty equivalent of deal A when Alex was Delta person, but he's not. Okay, how about option B? Okay, option B is $120, which is lower than $134. So when a person values an uncertain deal at a lower certainty equivalent, he is becoming more risk averse. So option B will correspond to the scenario where Alex is getting more risk averse as his wealth increases. So option B is not correct. Now option C, as deal changes from the original deal to deal A, which correspond to the fact that Alex has more money in the bank account, $100 in the bank account, and then is this winning either $100 and $0, his certainty equivalent, if his certainty equivalent is $140, then that is higher than $34 plus $100. That means Alex is less risk averse as his wealth increases. So option C could be correct. Okay. Now how about option D? Option D is interesting because now if Alex values deal A at option D, then it will indicate that he's becoming risk loving. Okay, if you look at the expected value of deal A, which is 0.5 times $200 plus 0.5 times $100, which is $150, this option D is higher than the EV of deal A. Okay, which means if option D is Alex's new certainty equivalent for this new deal, then Alex is actually becoming risk loving. Okay, so typically we don't think a person will switch from being risk averse to being risk loving. So option D is out. So the only possible option, the only option that makes sense according to the description of Alex is option C. Option A is what would happen if Alex is Delta person. Option B is what would happen if Alex is becoming more risk averse as his wealth increases. Option C is consistent with the description in the question. Alex is less risk averse as his wealth increases. And option D is changing Alex into a risk-loving person, which we don't typically assume for any person in the world. So option C is the only option that makes sense out of these four. Okay. Okay, these are some exercises for you to warm up to the idea of someone being Delta person or not. Okay. So, as a recap, the delta property gives us some very handy ways to analyze a person's decisions or values of different uncertain deals. Now, the first one is the certainty equivalent of an uncertain deal is independent of the person's initial wealth. So no matter rich or poor, a person values an uncertain deal at the same certainty equivalent. And the next thing is to say the second view over here, adding the same amount of dollars to the prices of an uncertain deal just increase the certainty equivalent by the same amount, delta amount. Okay. And the next thing is another very good thing about a person being delta person is that it will be super easy to calculate the value of perfect information for a person if she or he is a delta person. So actually, this is the next topic we're going to look at. How to value the perfect information or insurance for a delta person. Okay, so we looked at the value of perfect information before for Kim in the party problem. So we're going to use that example again here. So initially, this is the definition of value of clairvoyance, which is also named the value of perfect information. Here, we use this $VC to represent the value of clairvoyance. Okay, just a sort of a short-handed notation for us to use going forward so that the slide doesn't become too crowded with texts. Okay, so this is the definition. The value of clairvoyance is the maximum price that a person is willing to pay for clairvoyance in a decision situation. Okay. Equivalently, if you pay this value of certainty equivalent amount of dollars to get clairvoyance, you will be indifferent between paying that to get clairvoyance and not paying at all. Go with the decision problem without clairvoyance. Okay, so that indifferent relationship comes from the fact that value of clairvoyance is the maximum price that one is willing to say. So this is just a mathematical way, half mathematical way to say the second bullet point. Pay clairvoyance at value of clairvoyance gives you some value, gives you uncertainty equivalent of a decision problem. Do not get clairvoyance gets you a certainty equivalent of the problem. So these two should be the same. If you pay clairvoyant at a price that is lower than the value of clairvoyant, then this left-hand side would be higher than the right-hand side. If you pay a price that is above the value of clairvoyance in a decision problem, then the left-hand side would be lower than the right-hand side. You would be suffering from a loss if you pay for clairvoyance at a price that is higher than its value. Okay. Just to reinforce you guys with the idea that value of clairvoyance is the maximum price that you are willing to pay. It's not the actual price that you are going to be paying. This goes back to our differentiation between value in use versus value in exchange in our third chapter. Value of clairvoyance is the value in use that represents your personal maximum price, which is known only to yourself, and you do not necessarily need to pay that. You may be able to pay for a price that is lower than it if it is offered at a lower price. Okay. So this definition is the same definition that we used at the end of chapter 10. And this definition is true for everyone. Everyone, including a person who's risk-averse or risk-loving or risk-neutral, or anyone who is Deltaperson or not a Deltaperson. Okay, so no matter what kind of a person you are, regardless of your risk attitude, regardless of your Delta property, this is the definition of value of clairvoyance. Okay, so how do we get value of clairvoyance for a general person? Okay, so for a general person, in order to find that value of clairvoyance, you would start with some kind of best guess, say price P. So we analyzed Kim's party problem with a price at $15 for clairvoyance. So you just make a guess. And then if you find out that paying clairvoyance at that price gives you a higher certainty equivalent than not paying, then that P, well, it's not the value of clairvoyance because it requires to be equal. Then what you should do is to increase the price until this sign becomes equal. Okay, so now this scenario, you're guessing a $P that is too low. You should increase the price to find the threshold price that makes a person break even between these two. Well, if you find this is true, well, congratulations, you got it right at the first guess. Your value of clairvoyance is equal to P dollars. However, if this is what you find, that a person's certainty equivalent of the decision problem after paying clairvoyance at P dollars is smaller than the problem's value without clairvoyance, then you're guessing a price that is too high. What you want to do is slowly decrease the $P until this sign becomes equal. Okay, so these three are three possible scenarios after you start with some guessing on the value of clairvoyance. If this happens, no more work needs to be done. If this happens, you need to increase P slowly until it reaches an equal point. And if this happens, you need to decrease P slowly until this becomes equal. Okay. So that is what we plan to do for Kim before knowing she's a Deltaperson. So, oops. So this is what we analyzed before, right? We started with a guessing of $15 price, okay? The question is, this $46 is Kim's value of the party without clairvoyance. That's the top part of the decision tree. If you forget how to get here, look back at the videos for chapter 10 to see how we get the $46. Okay, so the question is, if we ask Kim to pay $15, what would be the value of the party problem? And this is what we get, okay? So originally, each prospect is worth this. This is the value of all different prospects after paying $15. Then we started from the end, then we analyze up until that we find Kim's certainty equivalent of this huge decision problem. Now, this is Kim's decision problem if she does decide to go with the clairvoyance service for $15. And that huge decision problem is worth $51. Okay, so now at this first guess of $15, the certainty equivalent of this route with clairvoyance is higher than the certainty equivalent of this route, this branch, which represent the party problem without clear ones. Okay, so this corresponds to the situation where we're guessing a price that is too low. Certainty equivalent with the price is greater than certainty equivalent without clairvoyant service. This is higher than that one. What we need to do is to increase this $15 gradually to $16 and see if this number is still higher than $46. We want to, the answer is yes. Okay, I'm going to omit the middle steps here just to give you the answer, but if you're interested, you can do that. And if you increase it, since $16 is also too low, that gives you a higher value over here, then you want to go with $17 and see if this number changes to a number that is equal to 46. The answer is still no. So you can increase it further to $18 and then $19 and then $20. $20 is the point where this number becomes 46. Okay, so the way that we analyzed that is I'm going to analyze this $20 price situation for you so that you can see why we have this equal relationship over here. So here is what the prospect's values are after paying $15. Well, if you're paying $20 instead, you would need to subtract a $20 value from all these prospects. So $80 is equal to $100 minus 20, 0 minus 20 is negative 20, 90 minus 20 is 70, you got the idea. And then what we need to do is to go from the end, from the red numbers, which are the values of clairvoyance at $20, then go back to mark the values at this node. Okay, so since this is a certain deal, so $80 over here, $70, $20. Again, this is no longer an uncertain deal. This is just a certain deal that the sunny day will happen. So that's how we go along this route. There's no chance that the weather will turn out this way. Okay, that's these three numbers. And then this is negative 20, 0, 30. So again, at this node, there's no way that the weather will turn out sunny. It will be rainy. So that's why the value of this deal, being no uncertain at all, is equal to negative 20, 0, and 30. Okay, and then go one step further. The value of this decision node is equal to the value of the best alternative, which is $80. Okay, and the value of this decision node is equal to the alternative with the best value, which is $30. Okay, so now you're looking at an uncertain deal with 40% of chance of receiving $80 and with 60% of the chance of receiving $30. Now what we want to find is what is the certainty equivalent for this uncertain deal. Okay, so this is uncertain deal because both probabilities are positive. These are not uncertain deals because you have 100% probability here. So over here, you would need to go through the steps. First, find the U values of these two prices on Kim's U curve. And that is when you should grab Kim's U curve that you have and then read from the U curve what are the U values of these two. Turns out these are. I'm going to omit it here. If you don't know how to do this step, again, review the video in chapter 10. And then the next step is to find the U value of this uncertain deal, which is equal to 0.4 times 0.89 plus 0.6 times 0.62. That's how we got the U value of this uncertain deal. And then the certainty equivalent for this uncertain deal is again something we need to read from Kim's U curve. As it turns out, it is $46. So this is what you would do for every step of the way. We did that for $15. You would need to repeat this process for $16, and turned out that this number is still higher than 46. You would repeat this exercise again for $17, which you will find that the dollar amount that you will get here after paying $17 is still about $46. And up until you do this for $20, you would get the same certainty equivalent up and down. Okay. Questions you might have at this point is, why are we increasing it $1 at a time? Well, you could increase it by $3, $2 a time. And at some point you will find, oops, I increased the price too high. Then at that point, you would adjust back down. So either way, you can do a lot of exercises until you find the $20 price point, where the certainty equivalent of paying clairvoyance is equal to the certainty equivalent of the party problem without clairvoyance. Okay. So this is a very tedious way to find value of clairvoyance for Kim in the party problem. Well, this is what happens if you know nothing about Kim, other than that she has given you her U-curve. Things will get super easy if Kim is turned out to be a Deltaperson. Okay, so again, look at this problem. This is what we get when Kim is paying $15. Now the question is, what if Kim needs to pay $20 rather than $15 for the clairvoyance service? And now we have the additional information that Kim is a Deltaperson. Then the exercise actually becomes easier. Okay. So this is what happens if Kim, this is the values of the prospects when Kim is paying $15. So paying $20 is just paying extra $5 based on the previous price, the $15 price. So let's do that. Paying extra $5 from the $15 price. That is equivalent to paying a price of $20. So as you can notice that what we're doing when we increase price from $15 to $20 is just subtracting the same amount of dollars from all the prospects, from all the prices of this uncertain deal over here, right? So if we know Kim is a Deltaperson, then we can directly get the certainty equivalent of this new deal by subtracting the same amount of dollar amount from her certainty equivalent of the original deal when she's paying $15 for clairvoyance. Okay, so that's how you can just ignore the middle steps. All the middle steps can be ignored, and you can just subtract the same amount of extra cost, extra price from the certainty equivalent of the previous deal. So 51 minus 5 is an easy calculation, which is equal to $46. This is how we know that Kim is valuing the clairvoyance at a $20 price. Okay, again, I'm jumping to the $20 point altogether, but you could do $15, $16. You know, if the price is $16, then this would be minus $1, an extra dollar of cost to get clairvoyance. Then this would be 51 minus 1, which is 50, still higher than 46. So you gradually adjust until 51. Well, you can just get the difference between the $51 and the $46, and then subtract that further down here. Then that will give you a certainty equivalent of $46, which is equal to the certainty equivalent of the party problem without clairvoyance. By definition, that $20 price is Kim's value of clairvoyance in this party problem. Hey, if you notice something, you started with $15 and just subtract $5. What if you start with paying nothing at all? Okay, you might as well start the problem with free clear ones where this column is no longer needed. And then figure out what is the certainty equivalent over here when the clear ones is priced at $0. And then take the difference between these two to get the value of clear ones for Kim, who is now known as a Deltaperson. Again, we're able to do this without the middle steps because we know Kim is a Deltaperson. That's why the new deals, after subtracting the same amount of dollars and the certain equivalent, you can just subtract it. If Kim is not a if Kim is not a Deltaperson, then after subtracting $5, this new certainty equivalent is not equal to 51 minus 5, which defeats the definition that you need to find the price that makes this equal to that. Okay. So here is the problem. Here is this approach. We might as well start with free clear ones, get the certain equivalent, take the difference. So let's see how that method works. Okay, here, these are the dollar values of different party scenarios, and we're looking at free clear ones, so we no longer need to subtract anything from it. And we repeat the exercise that we did for $15, $16, $17. And then, and then this would be 100, 90, 40, and then this would be 0, 20, 50. This decision would be 100, this decision would be 50. And then at this point, you will need to go to Kim's yield curve to find out the certainty equivalent. Because now you are looking at an uncertain deal where you have 40% of the chance to receive a sunny day party in the outdoor, or you have 60% of the chance of getting a porch party in the rain. So the way to do that is to get the yield values of these two. The yield value of 100 is 1. The yield value of 50 is equal to 0.67. And the yield value of the deal is equal to 0.4 times 1 plus 0.6 times 0.67, which is equal to 0.8. And then you go to 0.8, and then you go down, and that is $66. Okay. So this is the value of the party with free clear ones. Like I said, after you get here, knowing that Kim is a Deltaperson, you can just take the difference between these two. And that will be the value of clear ones for Kim. If you're sort of suspicious of the claim, now let's look at what if Kim pays the difference between these two, $20. Okay, then you would just subtract $20 from it. And knowing Kim is a Deltaperson, you skip the middle steps. You just subtract $20 from the $66. You get $46, which is equal to the value of the party without clear wand, which is the very beginning, the definition that works for anyone. Okay, so as it turns out, from the definition that works for anyone, we have got to a point that we can simplify the definition for a Deltaperson, which is just the value of the decision problem without clairvoyance minus the value of the decision problem without clairvoyance. Okay. Her value of clairvoyant is $20. So what I'm doing so far on this slide is to help you, to convince you that for a Deltaperson, take the difference gives you the same certainty equivalent as to going for the party without. Okay. You cannot do this. What this means is ignoring the middle steps for non-Deltaperson. Because, you know, for non-Deltaperson, if you subtract $20 You know, if you take the difference between free clairvoyance and clairvoyance and without clairvoyance and get that $20 to the end, then you will get a certainty equivalent that is absolutely not equal to 66 minus 20, which means you will end up with a certainty equivalent that is either higher or lower than $46. By definition, that $20 cannot be the value of clairvoyance for that person in this problem. Okay, so the blue box represent the certainty equivalent of a person who is not a Delta person who are paying $20 out here, who may initially have a $66 of value with free clairvoyance. Okay, so this is what we get. So after this exercise, we're now ready to sort of revise our definition on the value of clairvoyance for a Delta person. So this is true for everyone. A very general definition that requires you first to have a guess and then increase or decrease based on the result. This is true for everyone, but it's a tedious way to find value of clairvoyance. For a Delta person, you can simply do this exercise. We observed that the certainty equivalent of clairvoyance at a certain price is equal to the certainty equivalent of free clairvoyance minus that price. Notice here, at this price, the certainty equivalent is the certainty equivalent of free clairvoyance, $66 minus the price, because this is a Delta person. And then you put this expression to replace this left-hand side of the original definition. That is what we get here, okay? Replace this one with this new realization, and voila, you move this to the other side, move this to this side, then the value of clairvoyance is equal to the certainty equivalent of any problem with free clairvoyance minus the certainty equivalent of the problem without clairvoyance. Okay. So I want to stress that this way of definition, the subtraction method between free and no, only works for a Delta person. If a person is not a Delta person, you have no other way to find the value of clairvoyance but to go through the guessing and adjusting process. Okay. So whenever you have a Delta person, you do not need to go through the guessing and adjusting process, but you can just go ahead and analyze the person's value or certainty equivalent with free clairvoyance. Find that, and then subtract the value of the decision problem without clairvoyance. That subtraction, that difference, gives you the value of clairvoyance for a Delta person. Okay, so again, I want to stress this out. This only works for a Delta person. Okay, so we have looked at what the value of clairvoyance is for a general person, for a Delta person. Now we're interested in a third person who's even more specific than being a Delta person. Now, what if we're looking at a risk-neutral person? Okay, so we have already looked at the party problem for Jane, who is risk-neutral. The first thing to notice is that the value of the party for risk-neutral Jane without clairvoyance is no longer $46, it's $48. If you don't know how we got the $48, you should look at the videos in chapter 10, okay? Because now Jane's option, Jane's best alternative without clairvoyance in the same party problem is no longer indoor, it's a porch party, which has an expected value of $48. Risk-neutral person's certainty equivalent is equal to the expected value of the uncertain deal, which is something we revealed at the beginning of this chapter's lecture. Okay. Now, without clairvoyance, the party is worth $48 for gin. Now, what we know, so the thing that you need to know is that a risk-neutral person is a special type of delta person. Okay, I will talk a little bit more on that, but now what we want to do is treat gin as a delta person and then start analyzing the value of clairvoyance with a free option. Okay, so what would be risk-neutral gin's value of the party problem with free clairvoyance? Okay, again, free clairvoyance, so we're looking at the values of each party prospect as is. Gin just happened to have the same values of the different prospects as Kim. The only difference is that Gin has a different yield curve, which is a risk-neutral yield curve. Okay, so analyze the free clairvoyance party problem. Then going back, this is 100, 90, 40, 0, 20, 50. Decision here is 100, decision here is 50. This is actually the same with Kim's free clairvoyance problem. What differs is the next step, okay? Jane is facing an uncertain deal between 40% of the chance of $100 and 60% of the chance of $50. What we know for a risk-neutral person is that the certainty equivalent, that the number, the square over here, should be equal to the expected value of this uncertain deal. That means we no longer need to look at a yield curve for Jane. All we need to do is to use 0.4 times $100 plus 0.6 times $50, and that would be $70. Very easy. No need to do any complicated calculations if we know Jane is risk neutral. So Jane's value of the party with free clairvoyance is $70. Now, since Jane is a risk-neutral person and a risk-neutral person is a special type of delta person, her value of clairvoyance is just the difference between the two values. The value with free clairvoyance minus the value without clairvoyance, which is $22. Again, you can do this because Jane is a delta person who is a risk-neutral person at the same time. Okay, we don't need any utility graph at all at this point. Okay, so what I'm going to do now is to remember I have told you just up front that a risk-neutral person is a delta person. So now I'm going to show you quickly why is that the case. Okay, so if you are looking at a risk-neutral person, let's suppose you are looking at a person with $100 and $0, and it's a 0.5 chance. Now you are looking at a new deal for a risk neutral person. I want to mark it here that we are looking at a risk neutral person. Okay, and then what if we add $200 to each price? Okay. So again, we're looking at a risk-neutral person. As a matter of fact, we know that the certainty equivalent is equal to expected value. So we can just put over here at the position of certainty equivalent, we can just put the expected value over here, which is 0.5 times this plus 0.5 times 0, which is equal to $50. So the certainty equivalent of a risk-neutral person for this uncertain deal is $50. Okay. Now let's figure out when we add, I'm sorry, this is 200. When we add $200 to both prices, what would be the new certainty equivalent? Okay, so the person is still risk neutral. Risk neutral person is always risk neutral, doesn't change into risk loving or risk averse. That is what we know about people, I guess. And then the new expected value or the certainty equivalent would be 0.5 times plus $0 plus $200, which is actually, you can just get this $200 out, which is equal to actually $250. So if you compare the certainty equivalent of the new deal, where $200 is added to each price, with the certainty equivalent of the original deal, the difference between them is indeed $200, which is the same as the amount that is being added to all the prices. So if you know a person is risk neutral, then for any kind of uncertain deals, if you add or subtract the same amount of dollars of the prices, then the certainty equivalent would be going through the same change in terms of amount. That is why a risk neutral person is always a delta person. Okay, here again, I want to clarify that when we say a person is risk neutral, a person is risk neutral. A person doesn't change his type of preferences from being risk averse to being risk loving, from being risk loving to being risk averse, from risk neutral to being risk averse. We don't allow that kind of cross category changes when we are looking at changes in risk preferences. Okay, so that is how I want to explain to you that a risk neutral person is a special type of risk of a delta person. And with this example, we are ready to define the value of clairvoyance for a risk neutral person. So we know that a risk neutral person is a special type of a delta person whose certainty equivalent of any uncertain deal is equal to the expected value of that deal. So that is why with this, starting with a delta person's value of clairvoyance, we can just change this certainty equivalent into expected value, meaning we're no longer using U-curves. When we deal with the certainty equivalent of a delta person who's not risk neutral, we went through U-curve. Remember, for Jane, despite of being delta person, she is risk averse. So we went through the yield curve of Jane to figure out these two certainty equivalents. However, for the risk neutral Jane, for Kim, who is risk averse, who is a risk averse delta person, we went through her yield curve. For Jane, who is a risk neutral delta person, we didn't need any yield curve at all. Okay, so just to remind you, this is risk-averse Kim's decision problem. Kim is risk-averse and a delta person. We do need to use the yield curve to figure out both of these values. Okay, and this is Jane, who is risk-neutral. So we don't need yield curve to figure out either one of these two values. Just expect the value all the way along. Okay, so that is easier. Again, if you don't know how we find out this number, look at chapter 10's class video. Okay, and again, this formula you see over here with the least amount of calculation only works for a risk neutral person. So this is actually what you see on this slide is everything we need to know when we look at value of clairvoyance. Okay, it is the easiest to find for a risk-neutral person, a little bit harder for a risk-averse Delta person, hardest for a non-Delta person, hardest being the fact that you need to do that exercise a lot of times. Okay. Now the last topic in this second part of chapter 10 is now we're switching gear, sort of change our view from the value of clairvoyance into the value of insurance. Okay, so now we're ready to look at how can we decide the value of insurance in a decision situation if we know a person is Delta person. Okay, now here I'm just simplifying the analysis by ignoring a non-Delta person altogether. Now we're focusing on the insurance value for a Delta person. So what does insurance work? I think a lot of you guys may have insurance, health insurance, or if you are renting a home, you might have a renter's insurance. If you are you own a home, you might have homeowner's insurance. There are a lot. If you drive a car, if you own a car, you may have car insurance. Okay, the real life insurances work in a very complicated way, and if you're like me, I always got lost looking at a menu of insurance options when it is the time to change my health insurance each year. However, over here, when we look at Kim with the party problem, so what we want to start thinking about this insurance problem is looking at a super easy insurance. Okay, this super easy or super simple insurance works like this. With any insurance, you would need to pay a premium. Okay, let's assume that this insurance will require Kim to pay a premium of $B. And I'm using this B to represent any dollar amount. We're leaving it sort of arbitrary at this point. Okay, so the thing you need to know about insurance is sunny or rainy, you will need to pay up the insurance. If you think about a health insurance, you need to pay the premium no matter if you're healthy or if you've fallen sick. Okay, so that is how insurance works. No matter how complicated you are looking at, generally speaking, a premium is something you pay upfront, no matter how you turn out to be. This is almost like the price for the clairvoyance, that you need to pay up the amount no matter what kind of a message you get. Okay. However, the insurance will pay you back $50 if the weather turns out to be raining. The reason is that raining is always bringing down the value of the party for Kim. So the reason that she's ever interested in buying an insurance option for her party is to get compensated if the bad situation happens. Okay, relating to your health insurance scenario, the insurance company does nothing for you if you turn out to be healthy all the time. If you do get sick, that is when the insurance pays up the cost of your medical care. So this is just like that. If it turns out to be sunny, Kim just gets nothing back from the insurance company. If the weather turns out to be rainy, Kim gets back $50, sort of to compensate herself from the insurance company. Okay. Now the question is, what is the maximum dollar amount? Meaning, what is the maximum insurance premium that Kim will be willing to pay for this $15 insurance? Okay. So now you may be familiar with this way of thinking. When we are asking for a maximum price, we are looking at Kim's willingness to pay for this $50 insurance, which means when Kim pays the maximum price to get the $50 insurance, she would have a same value of the party as she would have without having the insurance. This is consistent, just like what we did for the value of clairvoyance. We first figure out what is the value of the party without clairvoyance. We figure out the value of the party with paying the willingness to pay price, then these two should be equal. That also works for the insurance problem as well. Okay. So what we want to do is just like what we drew for the clairvoyance problem. Remember when we do the clairvoyance value, we draw a new decision tree to represent Kim's decision of the party location when she hears from the clairvoyant. And here we also need to draw the new decision tree when she gets this insurance. Okay, so again, here I'm putting the original party problem as a reference so that we can draw the problem with insurance. So as a matter of fact, nothing changes in terms of the beginning part. The only thing that insurance changes is Kim's payoff in different scenarios. Okay. So at this point, in this prospect, where Kim have the outdoor party in the sunny day after paying premium, she would get the value of the party, and this insurance premium need to be deducted from it because she has already incurred this insurance premium before she have this party. So over here, you can imagine there is a branch here which says pay B dollars for insurance of $50 in rainy day. Okay, and over here, since in this prospect it is raining, Kim gets the original party value plus $50. This is the dollar amount that the insurance pays Kim. And again, minus B, because no matter what happens, the B dollars is out and gone. Okay, the insurance premium is out and gone no matter what scenario, what prospect Kim faces in the end, at the end of the day. Okay, so over here, similarly, porch party in the sun is worth $90. Don't forget the B dollars are out of the way. Rainy day party in the porch is worth $20, but since it is raining, $50 is paid out to Kim by the insurance company. B dollars out anyway. And here, $40 minus insurance premium. $50 plus $50. Here, the second $50 is from the insurance's compensation and minus B. So actually, this new decision tree represents what happens after Kim pays B dollars of insurance premium to get $50 compensation for rainy days. Okay. Now the next question is, what is Kim's willingness to pay? So what is the B amount? What is the amount of B dollars that makes Kim have a certainty equivalent of $46 for this party problem? $46 is the party problem's value to Kim without insurance. Keep that in mind. Okay, so since Kim is a Delta person, just like when we have a Delta person, when we look at the value of clairvoyance, we can start with a free insurance option. And then we take the difference between the value of the party with free insurance minus the value of the party without insurance. And that difference will be Kim's maximum price that she is willing to pay to get this $50 insurance. Okay, so let's start with free insurance. Free insurance meaning you are paying $0 in premium. So these B dollars will be gone. Okay, so that's what we're going to do. Okay, so now it becomes $100, $50, $90, $20, $40, $100. because B is equal to 0, because we're looking at free insurance. That's how we got these numbers. Okay, now what we need to do is to figure out Kim's value of the party with this free insurance option. The way to do that is similar to what we did for Kim's party problem without insurance at all, because recognizing that now outdoor is leading to a binary deal between $100 and $50 rather than $100 and $0. So we need to figure out the certainty equivalent of this uncertain deal that comes after the alternative of outdoor party. And that is what we're going to do. So the way to do that is, again, to find the U values of these two, find the U value of the uncertain deal, find the certainty equivalent to give a U value of 0.8. So that is it. And then we do that for this problem. U value of 90 is 0.95. Again, this comes from Kim's preference, Kim's U curve. I'm not doing that anymore because we've done that so many times. And then the U value of 70 is this. And U value of the new porch party with the insurance compensation here, originally it's $20, now $50 is added. And the U value is 0.87, and the certainty equivalent is this much. And to do that for indoors, the certainty equivalent is 69.85 cents. Again, when we say free insurance, we mean that the insurance premium is 0. The insurance is given to Kim for free. It doesn't mean that the insurance company is not paying anything. The insurance company is paying $50. This free insurance refers to such an insurance that Kim pays nothing in premium, but get $50 when it is rainy day. Okay. So now what is the value of this party with free insurance? Again, the value of this party problem, the value of this square node is equal to the value of its best alternative, which is $77.35 over here. So Kim should pick porch party if she does get insurance. Okay. Value of a free premium $50 insurance is 77.35. Now, since Kim is a Deltaperson, the most that Kim is willing to pay for this $50 insurance is equal to this 77.35 minus the value of the party without any insurance. That would be $31.35. Okay, so if the insurance company offers Kim the $50 insurance at a higher price, Kim would reject. Kim would not want to insure her party for $50 in the rainy day. If the insurance company offers the $50 insurance at a price lower than this value, then Kim would be willing to pay that premium and get the $50 on rainy days. So I want you to think about how much the insurance company is expecting to pay. Okay, so the insurance company pays $0 if it turns out to be sunny. The insurance company pays $50 if it turns out to be rainy. So let's assume that the insurance company have the same belief in terms of how likely it is going to be sunny and how likely it is going to be rainy. So that means the insurance also believes that 40% of the chance it's going to be a sunny day and 60% of the chance it is going to be a rainy day. Then with that two pieces of information, we can see that the insurance in expectation would be paying this much money to Kim. Okay, this is the expected value of insurance's payment to Kim, which is equal to $30. Now the insurance company needs to run itself, so it may require some act. So this $30 represent the company's cost to offer the $50 insurance to Kim. And then there are some administration fees. So if this insurance company offers Kim a premium of $0, then this need to be paid out and this need to be added on. So now it is costing the company some less money to give Kim a higher benefit of $31.35. So as you can imagine, if you can strike a deal between Kim and the insurance company, say if the two of them agree on an insurance premium of $30.50, then both Kim and the insurance company would be better off than without the insurance, right? With 30.5 insurance premium, Kim has a surplus of 85 cents of surplus. That is 31.35 minus 30.5. Now with the company, it has again, so it gets $30.5 from Kim, but in expectation, the company only need to pay $30. So that 50 cents is what the insurance company would gain from that transaction. We're assuming there is no administration fees, but if you add something like 25 cents of administration fees, that will strip the profit of the insurance down from 50 cents to 25 cents. But regardless, both parties can be better off. Okay. So in that scenario, insurance is helping the society by bringing everyone to a better position than the scenario where we don't have any insurance at all. Okay, the difference between the cost of insurance and the benefit of Kim in this scenario is rather small. It's only $1.35. But in real situations, the difference between the benefit to people versus the cost of the insurance can be large. And in that scenario, insurance company can be very helpful to bring the society to a better status by making everyone better, by making profit by the insurance company and making the consumers of the insurance plans to a better scenario. Okay. So this is just a summary. So certainty equivalent and then value of perfect information for Deltaperson is certainty equivalent with free clairvoyance minus no clairvoyance. Value of insurance in a decision for a Deltaperson equals to value of that decision with free insurance minus value of decision with no insurance. Here, I'm bolding and enlarging this Deltaperson condition to have you keep it in mind that this minus method only works for Deltaperson. Okay, now risk neutral person is a Deltaperson who values uncertain deals at the expected values. So for a risk neutral person, the value of a decision or the certainty equivalent of a decision is equal to the expected value of that decision. So you can replace these certainty equivalents to expected values. One more time to emphasize that you cannot use the subtraction method for a non-Deltaperson. You will need to use the guessing and adjusting method for a non-Deltaperson. If you do know a person is a Deltaperson, you can go ahead and using these two formulas to figure out value of perfect information and value of insurance. Okay, so this is the end of the first two classes of chapter 11. So the next two classes of chapter 11, we will be looking at the utility function of a delta person. Okay, when we say a utility function, you should be prepared to look at some mathematical formulas. Okay, we're no longer interested in how we can represent a person's utility curvature using U-curve. We're interested in how we can use a mathematical function to represent a person's U values. And then we'll look at what is risk odds and how that can capture a person's risk attitudes.